Alright, so today we're doing 7.2, which is theoretical and experimental probability, and we're going to find the probability of these two events. Okay, the main difference you'll notice between theoretical and experimental is theoretical is what should happen, and experimental is
What really does happen.
what actually happens. Okay, so we're going to define a few things. First, probability. So that's the measure of how likely an event is to occur. There's different ways that we measure probability in terms of how we're writing our answer. We're going to have some that are fractions, decimals, and as percents. The outcome is what the result is of your situation. And then sample space is probably something new. This is the set of all possible outcomes. And then when we're talking about an event, that is an outcome or a set of outcomes for a specific event. Okay, and then you guys have a space down here for theoretical probability. In the complement, we are going to read over page 490 and then fill those in. Oh, and your book has a nice little thing about Battleship. You guys ever played Battleship, the board game? So, you can find the probability of hitting the target in the game after today's lesson. So, we just defined all of these values. Here are a couple of situations we'll talk about today. So, rolling a number cube, when it says number cube, it's just a die. Okay, so 6-sided. Or spinning a spinner. And the spinner sometimes will have colors, sometimes it'll have numbers on it. The sample space of the number cube would be the numbers 1 through 6. For this spinner, the sample space is red, blue, green, and yellow. Your probabilities can be found on this chart here. So if it's impossible, as a decimal, that would be 0 or 0%. If you're certain, that's going to be 1 or 100%. And then if it's halfway, they show you 0.5, 1/2, 50%. We'll be writing out today these three different formats. Okay, percentage, decimal, and fraction. All right, so theoretical probability. If you have equally likely outcomes, we're going to write this down. The probability in an event is going to be the number of favorable outcomes over the number of outcomes in the sample space. And we're going to just say that as the total number of outcomes. And I'm going to write that on the sheet for you so you can just see it easily. So for equally likely outcomes, okay, the probability of an event, you can tell me if you can't see it. Yeah. Okay, so this is going to be the number of favorable outcomes over the total number of outcomes. So the number of favorable outcomes, that's just what you want to happen. And then the total number is all of your possibilities. Okay, so this is a good rule of thumb to follow. So what you want to happen over what could possibly happen. Okay, and that's the number of outcomes in your sample space. Okay, the complement is going to be when the event does not happen. So the complement is going to be the probability of not E. So when it says not E, that means not the event happening. So with probability, the highest value is 100% or 1. So to find the complement, you just have to do 1 minus the probability of the event happening. Okay, for example, if there's a 20% chance that we have a snow day on Monday, what's the percent chance that we do not have a snow day? 80, because if you do 1 minus 20%, you get 80%. Okay, so that's what the complement is. You just do 1 minus your event. Okay, so 1 minus the probability of the event happening. For example 1, each letter of the word probable, P-R-O-B-A-B-L-E, is written on a separate card. So each letter is written on a separate card. The cards are placed face down and mixed up. We're going to find the probability that a randomly selected card has a consonant. And do you guys know what a consonant is? Not a vowel. Okay, so we're going to do the favorable over the total. And normally I will find the total first. Okay, and that is usually simpler to find. So to find the total, we just have to know how many total letters there are. How many total letters are there? 8. Okay, what we are trying to find, the favorable outcomes, are the consonants, not vowels. Okay, so let's list out what those are going to be. So P, is that favorable? Okay, what about R? Yes. O? No. B? Yes. A? No. B, do we have to put B again? Yes, because it's on 2 different cards, right? So if it's on 2 different cards, we have to count it twice. And then L, and not E. So we have 1, 2, 3, 4, 5. Okay, so 5 cards with consonants. So we're going to write our answer as a fraction, as a decimal, and as a percent. Okay, so this would be 5/8. Whenever you're rounding the percent, you can round the percent to the nearest tenth. Some of these we'll talk about like how to do them without our calculator. So we have 0.625, so if it's an exact decimal like that, we're going to keep it. And then to turn your decimal into a percent, what do? Multiply by 100, which is just moving the decimal 2 places. Okay, so 62.5%. All right, for example 2, 2 number cubes are rolled. So again, that would be a pair of dice. What is the probability that the difference between the 2 numbers is 4? So first, let's think about what all of the possible outcomes are, okay? So if you're rolling a pair of dice, I'm gonna just write this out for you first. The first die could be 1. The second die could be 1, right? That's the first option. The first die is 1, the second one could be 2. The first one's 1, the second one could be 3. Could be 1, 4, 1, 5, 1, 6. If the first die is 2, then the second one could be 1, could be 2, 2, 2, 3. See where I'm going with this? Okay, and that would continue. In your book, on page 291, they give you a nice little chart here that shows you all the different possibilities. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and then the 2s, 3s, 4s, 5, 6 here. How many total do we have? We have 36, right? We could also use what we did yesterday with the fundamental counting principle, because with the fundamental counting principle, if you're rolling 2 die, how many options do you have for the first die? 6. How many options do you have for the second one? 6. 6 times 6 is 36. Okay, so anytime you have a pair of dice, your total is going to be 36. Okay, so now I want you to write down the favorable outcomes, which is where the difference between the two numbers is 4. Okay, and I want you to write down what those options are. Okay, and I'm going to put this chart back up there to help you. Okay, so Max, what do you think? What's one option where the difference is going to be 4? Okay, so 6 and 2. So you could roll a 6 on the first die and a 2 on the second one, right? Would 2, 6 also be an option? Yeah. And it would be a different option because the first die could be 2, the second one could be 6. All right, and then Maria, what's another option? Yep, you could roll a 1 and a 5, and then the fourth option would be a 5 and a 1. Okay, so then there would be 4 out of 36. If you're writing your answer as a fraction, it always needs to be a reduced fraction. Okay, so that's something that we're going to practice. So 4 goes into both itself and 36. So this is going to reduce to 1 over 9. Okay, and do you guys know what 1 over 9, 1 divided by 9 is? Yeah, it's 0.1 repeating. So in that case, normally what I'll do for the decimal is like round it to the nearest 1,000th, or you could even put 0.1 repeating is fine. And then for your percentage, 11.1% is your rounded answer. Good. Questions for me so far? All right. Example 3. There are 25 students in study hall. The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? And then I have to give you the values in the table. Yeah, I haven't given it to you. Okay, so we're trying to find the probability of not studying a foreign language. So for French, bonjour, there are 6 students. And Spanish, hola, there are 12. And Japanese is konnichiwa. How you say hello? Konnichiwa. You guys know? Everything I know about language I learned from Sesame Street. So gotta go back and watch Big Bird Goes to Japan and figure it out. Okay, so if there are 25 total students in study hall, this is showing us who has a foreign language. Okay, what we can do is use the complement. So we can find the probability of the foreign language takers, or students, and then once we find that, we can use the complement. Would be 1 minus P of the event, or the foreign language students. Okay, so to find the foreign language students, I can just count these up. 12 and 3 is 15. What's 15 and 6? 21, right? So 21 out of 25 total students are foreign language takers. So when I do 1 minus 21 over 25, I know you guys are already thinking about this, right? How many more do I have left over? 4. So this would be one where you already have a reduced fraction, and we could find this percentage without using our calculator, because 25 times what is going to be 100? 4. So 4 times 4 is 16. So this is exactly 16%. Okay, when you're doing 1 minus, you're subtracting from your denominator, 25 minus the 21. Okay? All right. In our next situation, a student receives a 5-digit locker combination. What's the probability of receiving a combination with all odd digits? Pardon?
What's the highest number like?
Yeah, so it's 5 digits. Okay, so each digit, what would be the possibility? So we're gonna do the favorable over the total. I know, I see you weren't here yesterday, we talked about it. Okay, so we're gonna do the total first. Okay, so when we're thinking about the total, yesterday we talked about the digits, right? How many total digits are there? 10. Okay, so it could be 0 through 9, which means there are 10 digits. And we can think of this like we did yesterday. If there's a 5-digit code, right, it's like you have 5 different spaces. I could have any of the 10 digits in any of the spaces. Okay, you could repeat those. So it would be 10 to the 5th, right? 10 times 10 times 10 times 10 is just 10 to the 5th. Let's think about how we could do this without our calculator, and you can check it on there. But what's 10 squared? 100. What's 10 cubed? 1,000. So notice that if you do 10 squared, the answer has how many zeros? 2. And then 10 cubed has 3 zeros, so 10 to the 5th is going to have 5 zeros. So then the total possibilities are going to be 100,000. All right, now let's talk about what is going to be favorable. So favorable is that they are odd. Okay, so the odd digits your odd digits, if it's from 0 to 10, right, is 0 an odd number or an even number? Even, because everybody gets nothing, right? We can all share in the nothingness. You can split it up evenly. Okay, so 1, 3, 5, 7, and 9. So there are 5 odd digits. And then again, it's a 5-digit code. So you're going to have 5 each time, which is just going to be 5 to the 5th. And we can use our calculator for that. I just thought it would be cool for you guys to realize the 0 thing, if you didn't already know it. Okay, and then you get 3,125. So those are your favorable. Okay, so we're going to have to write our answer as a reduced fraction. So when we set up our fraction, the 3125 over the 100,000, obviously what number goes into both? 5, okay? Obviously, that's going to take a while because it's such a small number and these are such large numbers. what I always like to try first is dividing the top into the denominator. And then if that doesn't work, then I'd probably try 25 because that ends in 25. So let's see if that does work. If I take 100,000 and divide by 3125, do I get a whole number?
Yes.
Yes. Okay, so that means I can reduce this when I divide each one by 3125. Okay, so that would be 1 over 32. Okay, so then 1 divided by 32. See how that's a decimal that doesn't keep going? Your 0.03125. So I would leave it like that. Okay, and then we can multiply by 100 or just move the decimal 2 places to get 3.125%. All right. For example 5, we have a DJ, and she selects 2 out of 8 ads to play before her show. 2 of the ads are by a local retailer. What is the probability that she will play both of the retailer's ads before her show? So there's a couple different ways that you can think about this. The first thing we're going to consider is your total. Okay, so how many total ways can she play these 2 ads? So like we do here with the digits, she has 2 ads, right? How many choices does she have for the first ad? 8. Once she plays an ad, okay, that's not going to be in rotation anymore. So how many ads would she have for the second one? 7, which is going to be 56. Using what we learned yesterday, we could also think of this as, oh, this is a sequence. When you have a sequence, the order that you're playing in matters. So you could also do, out of 8 ads, you're choosing 2, you could use a permutation. And if you did the 8 permutation 2, again, you would get 56. Okay, so the total is 56. 56 ways that she can play 2 ads out of the 8 that she has. Now we're going to look at the favorable. So remember, what we want to happen is that she plays 2 ads from the same retailer. So how many total ads does that retailer have? 2. So she only has 2 choices here, and once she plays one, she has only 1 more choice to play there. Again, because your order matters, you could do 2P2 and you'll get the same thing. Alright, so we're going to write our answer as a fraction and a decimal. Okay, so the probability is going to be 2 out of 56, which reduces to what? Yep. And then we're going to divide this. So 1 divided by 28. See how this is a decimal that keeps going? So we'll just round that. And I round that to the nearest 1,000th so that I can round the decimal to the nearest tenth. So 1, 2, 3.6%. Alright, now I know that many of you miss geometry, so we're going to incorporate some geometry into the next probability. Okay, so geometric probability, we're going to be working with area. So not too bad. No ortho centers over here. You guys remember that? proves, yeah. Right, so a figure is created, we have it right here, by placing a rectangle inside of a triangle inside of a square, and that is shown. If a point inside this entire figure is chosen at random, what is the probability that the point is inside the shaded region? Okay, this is like throwing a dart at a dartboard. It's just our dartboard is a square inside of a triangle inside of a rectangle. The shaded region, can you guys see that pretty clearly on your copy? Okay, so the total amount, anytime you're doing the probability for geometric, is going to be the total area. So in this case, that's going to be the area of the square. On the top is going to be the area of the shaded region. Okay, so let's figure out how we can do the total area first. Okay, so the total area is the area of the square. So this whole shape here. And what is the length of each side of the square? 9. And you can see that here too, right? 3 plus 3 plus 3 is going to be 9. So the area of the square is your side squared, 9 squared, which is going to be 81 centimeters squared. All right, how could I say what the total area is of the shaded region? Yeah, in terms of the shape, how would we find it? Why are you doing 1/2 base height? Okay, so it's the area of the triangle, but part of it's cut out, right? Okay, so we're going to find the area of the triangle, and we're going to subtract the area of the rectangle that's inside it. Okay, so to do the area of the triangle, we are going to use 1/2 times base times height. Rectangle, length times width. Do we know what the base and the height is of this triangle? 9 and 9, right? So here, remember it's a square, so this is a right angle. So this height is the height of the triangle as well. So 1/2, 9 times 9. Should be 81 over 2. Okay, what's half of 80? 40, so this would be 40.5. All right, and then we're going to find the area of the rectangle, which will be 4 times 3, 12. Okay, so then when you subtract 40.5 minus 12, what do you get? 28.5. All right, now we are going to have to make our fraction. Okay, so then our probability is 28.5 over 81. Now, a lot of times when we do this, we are going to write it as a decimal, but let's talk about strategies for writing this as a simplified fraction. And this one really isn't too bad. What's the only thing you have to do to get rid of the decimal in the fraction here? Multiply by 2. You could also multiply by 10 over 10. We're going to multiply by 2 over 2, because 28.5 times 2 . Yeah, so do 28 plus 28, and then you can add in your 1, so you should have 57. And then 81 times 2, 80 and 80 is 160, so 1 and 1 is 162. Okay, now if you're reducing this number, because we are going to practice reducing fractions, if you're reducing that number, okay, really, I said the first thing that you should check is what? That's the first thing I said that I would check with one of the earlier ones. Yeah, does the numerator go into the denominator? So 162 divided by 57, okay? It doesn't go in there evenly. So now I'm going to start and I'm going to see if they're both even. Are they both even? Nope, so then I wanna see if 3 goes in there. Does 3 go into both? How do I know right away? Yep, and if you add up the digits, then it's a divisor of 3. So 5 plus 7 is 12. 12 goes into 3. 1 plus 6 is 7. 7 plus 2 is 9. So yeah, 3 is going to go into both of them. So let's divide them both by 3. 57 divided by 3 is 19. What's special about 19? It's a prime number. So when I divide 162 by 3 and get 54, if 19 doesn't go into 54, I can't reduce this anymore. And I know it doesn't, because if it did, the top would be 1. And if the top was 1, what would have happened? If this simplified to 1, then when I tried to divide 57 in here, I would have been able to do it already. Okay, so then 19 over 54 is going to be your fraction. And then we're going to write this as a decimal. Okay, so 0.352, which is going to be approximately 35.2%. Be careful, earlier at first I wrote 3.52%. I was like, wait, that's not right. So compare the shaded region to your percentage. Okay, so reasonably you can see with your eyes that this would be greater than 3.5%, right? Because of how tall this is. Okay, so make sure that visually it also makes sense. Okay? All right. Now, experimental probability. So experimental probability has a different equation than the theoretical. So experimental probability is the number of trials over the number of times the event occurs. Okay, so how many times this actually occurs over your total number of trials. And we're gonna do an activity with that on Monday, which is why you need a coin. All right. For example 7, the table shows the result of a spinner experiment. Find each experimental probability. Okay, so I'm gonna just draw a spinner for fun here. So this spinner, it says number 1, 2, 3, 4. So this spinner had numbers on it. You guys play some games that have spinners on them? I'm trying to think of one. Is there a popular board game that has one? Oh yeah, Twister is one. Right hand blue.
We should play Twister. That'll be our final.
And then, oh, I love that game. Pretty Pretty Princess. Oh, brings me back. I probably have it in my basement. I definitely.
I have a real question. Why do you know this, Ian?
Because he has he's
I
a
have
sister.
sisters. I do too. I've never heard of that game once.
Then you are missing out.
I don't even know that game.
We'll talk about that after we do this.
Can that be our final?
No, but it is really cool. All right, so what we have to do first is we have to find the total number of trials. How can I find them in this chart?
Add them up.
Add up what?
The occurrences.
The occurrences. Okay, so then the total number of trials is going to be the occurrences. I promise we will Google Pretty Pretty Princess after this, and I will show you guys all the glory that is involved in that. Okay, so then let's add these together. Hey, if you to do this in your head, look at this. See how this is 19 and 11?
30.
So see how if you take the 1 here to make 20, and then you have 30, right? And then look, 6 and 14 makes 20. Bada boom, bada boom. 50. Okay, so our total is going to be 50. All right, so we're going to do spinning a 4. So out of 50 trials, Kira, how many times was a 4 spun?
14.
Yes, so 14 out of 50 would be your probability, and you're always reducing your fractions. Reduce. Okay, so 2 goes into both of them, divide by 2, you'll get 7 over 25. This is a case where you would not use your calculator to find this, right? Because remember, if it's 25, 25 times what is 100? 4. So 7 times 4 is 28, so this is just 0.28. Not approximately, it's exactly 28%. There you go. All right, for spinning a number greater than 2. So if it says greater than 2, what would that include?
3 and 4.
That would include spinning a 3 or spinning a 4. Okay, so if it's just greater than 2, that would be spinning a 3 or 4. Okay, so spinning a 3 is 19, spinning a 4 is 14, so we're going to add those together, and then your total is going to be 50. Okay, so then we'll have 33 out of 50. That will not reduce, right? Because all of those are just our basic math facts. And then when you are finding this, again, 50 times what is going to be 100? 2, so just times 2. Times 2 times 2, so 0.66, which will be 66% exactly. All right, spinning an odd number. All right, spinning an odd number. And this spinner means you're spinning a 1 or a 3. So 6 times we spun the 1, 19 times. What's 19 plus 6?
25.
Thank you. Okay, so we're going to reduce that. Hopefully we recognize that as 1/2 or 0.5 or 50%. Okay, I'm going to have you create your own event, but I'm going to be your classmate, and I'm going to tell you what to do for E. Okay, so for the last one, I want you to do the event of not spinning a 4. Okay, because what do I want you to practice with this one? The complement. Yeah, so didn't we already find the probability of spinning a 4? So this would just be 1 minus the probability of spinning a 4, which we already found is 7/25. So 1 minus 7/25. When you're doing the subtraction, remember that the whole is just the denominator from this. Right? And some of you probably think of it as adding. Like, what could I add to 17 to get to 25? That would be a good way to think about it too. So 25 minus 7 is? What is it? 18. So we have 18 over 25 times 4 times 4. Okay, if we're doing 18 times 4 without a calculator, let's just do 18 times 2, which is what?
36.
36. 36 plus 36 is?
72.
72. So then it would be 0.72, 72%. And if you compare it with this, 28 plus 72 should equal what? 100, and it does. Okay, so will you do an event? I'm fine if you and your elbow partner want to come up with the same event. So write what your event is and what the probability is. And while you're doing that, I'm going to pass out your homework.